Hi, and welcome to episode 43 of the Trending Tech Podcast, brought to you by the team at IoT-now.com and vanillaplus.com. For this episode of the podcast, I'm joined by Sam Colley, who's the head of connectivity strategy at G&D. But first, a warm welcome to all of you around the world who are listening in. In a change to your usual host, I am Matt Hatton. But to keep things nice and simple, as with Jim Morris, your usual host, I'm also co-founder of Transforma Insights, a firm of industry analysts focused on all things related to IoT, AI, and digital transformation. Today, the topic is the evolution of IoT connectivity, how eSIM is shaping its future. And that's a fortunate topic for me, as it's a particularly big focus area for my research. We recently published extensive research on eSIM, particularly looking at the new SGP32 standard. And back in July, I unveiled our annual communication service provider benchmarking report, which looks at all of the key trends related to cellular IoT connectivity. So all these things are very much front of mind to me. But Sam, welcome to the podcast. It's great to have you as a guest.
Thanks for having me, Matt. Nice to be here.
Excellent. Before we start that discussion on eSIM and how it's changing IoT connectivity, let's take a quick look at some serious technology news stories that Sam and I have spotted this week. Sam, I'll let you go first. What have you seen that's interesting?
I noticed an article, basically, it was a kind of released by Panasonic, and it was interesting talking about IoT security, which I know is a huge topic and one that comes up all the time. But I think it was interesting because it was kind of giving some dire warnings about the current state, really, of security in hardware devices, and really kind of what that means for the market, particularly as we see kind of the attack cycles get shorter and malware becoming more advanced. And really, they were talking about the need for this kind of continuous protection approach within hardware and beyond, but they were specifically focusing on hardware and how these devices need to be able to evolve once they leave the factory, because you can protect something today, but tomorrow it's vulnerable again. And I think for me, it kind of resonated because we see this all the time. There's a lot of talk about security, but this kind of who's taking the burden of the security kind of evolution on the cost, essentially. And that's always been a challenge in terms of combating that. But what Panasonic are suggesting, or what they're going to do, is they're going to proactively create lots of honeypots around the world and encourage these attacks so they can actively learn. And then kind of a positive spin on the article, so it wasn't all doom and gloom, was that they will then share this information more broadly in the IoT ecosystem to try and combat this growing threat, which for all of IoT's potential, the security question mark is still something that kind of looms over its head a little bit. So yeah, that was something that I found particularly interesting this week.
Yeah, it's clearly always been one of the critical issues and one of the things that perhaps has held IoT back a little bit. And we've seen a load of regulations come through, right? Last probably 3 or 4 years, a huge amount of regulation related to security. But I think that's necessary but not sufficient is how I describe it. And, there's a big element of a chain's only as strong as its weakest link. And there's a lot of different links within the IoT space, and that kind of idea of sharing all of these best practices and sharing what the challenges are around security, I think actually maybe that makes sense.
I think a lot of sense, actually. I think one of the good examples of where maybe something doesn't quite go far enough is the recent kind of FCC announcements where, they're creating a watermark or a label that you can achieve for your hardware if it adheres to certain criteria. That's a perfect example of really where you're not addressing all of the different threat planes within the IoT ecosystem. And you can have the safest device technically in the world, right? But if you've got an exposed cloud infrastructure, then you're still not necessarily securing the application end to end. So that engagement and collaboration that you mentioned, I think, is going to be really fundamental moving forward in order to combat this growing threat.
Yeah, no question of end-to-end is probably the important one, because there's always a question of who's responsible. And the answer is everybody's responsible. But then if everybody's responsible, maybe no one's responsible. It's a challenging thing. Anyhow, all good stuff. Let's move on to my serious news story for the day. And for us, it's, in fact, one of our own, little plug for some research that we published as part of a free white paper that we released this week. And that's looking at the need for supporting voiced services for IoT. And as part of that research, we found that almost 20% of cellular IoT connections and 22% of connectivity revenue, which amounts to $80 billion, have a requirement for supporting voice. And The most important of those would be connected car, but there's also numerous other use cases around worker safety and vertical transportation, assisted living, and so on. And in many cases, there's a regulatory driver for supporting, for instance, emergency calling for recall. And there's a lot of options for delivering voice. And in fact, really, even describing it as voice in its own right is perhaps not entirely accurate. There are many forms of voice, whether it's push to talk or emergency notifications or two-way concierge support or whatever. But historically, on cellular connections, you'd use fallback to 2G, 3G. But with the sunsetting of 2G, 3G networks, that's not really a viable approach. And so that leaves a couple of options. You can either go with a native IP-based voice in the form of voice over LTE or voice over new radio when we get to 5G, or you go with some sort of over-the-top voice service like a WhatsApp, but I mean, obviously not, but similar to that kind of approach. Now, what the most appropriate will be depends on the use case, but conclusion was most of the use cases actually have quite a significant requirement for security, compliance, reliability, flexibility, and a few other things, which mean that really it's going to focus on that circuit switch or the VoLTE VoNR form rather than the OTT voice. So voice, we don't tend to think of IoT as a voice thing, but lots of IoT applications demand voice. So that was our one. Sam, I don't know whether you had any thoughts on that one. It's a little bit esoteric, a very specific piece of research that we did, but if you do.
Yeah, so in terms of just what we see coming from the market, obviously the majority of applications don't require it, but there are still the applications that you mentioned that do. And we see mainly the demand coming for the VoLTE kind of implementation as well, in terms of, what's the least complex to implement, right? I mean, if you're looking at an over-the-top type service, then often you're going to have an additional application on the hardware, and often, particularly for kind of lightweight devices that have very low-cost hardware, etc., then there's often not a lot of space left for much to kind of be put onto the device, and we're seeing that, and we'll talk about it later with the new standards for SGP32 as well in the eSIM world as one of the potential drawbacks there. But yeah, so I mean, the module manufacturers really, obviously, if they can support the VoLTE on the modems, even down in the Cat-M kind of category of modem, then I think that should be readily available, as long as the supporting networks can also support the VoLTE environment, and maybe even in a roaming environment, which can also be a challenge. So there's a few things that stand in the way, but I think technology is moving on, and the understanding of what's required is also becoming clearer. So yeah, it's an interesting topic, and one that kind of isn't always coming up, but when it does, it's usually for interesting opportunities or applications like you mentioned.
Yeah, that's kind of what we thought. It's an area that's not really looked at a huge amount, but it sounds like we're pleasantly in alignment. That's a good thing. Okay, on to our main discussion. The evolution of IoT connectivity, how eSIM is shaping its future. As I mentioned in the intro, it's this area around eSIM is certainly one that we've been delving into in quite a lot of detail, and the impact that it will have on connectivity. But we're not here to talk to me, we're here to talk to you, Sam. So, but just to kick off, really, as a bit of background, a lot of people are going to be familiar with G&D, manufacturer of SIMs, bank cards, and banknotes even. But can you give us a little overview of what the company does as a global connectivity provider, and particularly related to eSIM?
Yes, well, I was going to give you just a two-line introduction to G&D as a whole, because I think it is relevant to some of the other conversation topics as well. Because G&D basically obviously goes way beyond just connectivity, eSIM and SIM cards, and it's been securing the kind of data transactions of individuals throughout its business, basically since its inception, whether that was banknotes to start with and the security there or beyond. But it defines itself as a security tech company, and basically across all its divisions, it deploys these kind of security solutions. And really, I think of it as like protecting your pocket, right? So all of them are kind of like personal data security solutions, and it was then the first obviously company in the world to develop the SIM card, and so they just have a long history of protecting personal data. In terms of the connectivity and eSIM, G&D's proposition is somewhat unique. We're the only company really that globally that can offer a fully integrated and owned connectivity eSIM SIM stack from top to bottom, so all the way down into the operating system on the SIM, all the way through to the core network. We own that stack in its entirety, and therefore that really allows us to add some pretty cool value-added technology within that ecosystem, really empowering enterprises to connect their devices faster, more affordably, and more securely, hopefully moving forward. So, yeah, as I say, I think it's quite a unique position to be in.
Yeah, that's the kind of overview picture. Let's drill in a little bit. I said we were going to talk about eSIM, but a lot of the background on eSIM is really rooted in the change from the physical plastic SIM to the embedded soldered SIM. And actually, there's even a little bit of confusion around terminology, right? What do people mean by eSIM? I tend to use the term embedded SIM because that for me is a physical element. Whereas when people talk about eSIM, often they're referring not to the physical thing itself, but to the functionality associated with it. So Can you talk me through that a little bit?
Yeah, I think it is definitely thrown around and therefore creates some confusion. But I think it's also important to state that eSIM technology itself isn't limited to embedded hardware, right? And it can be deployed on any UICC that has eSIM technology enabled or an OS on it that supports it. So if you aren't ready for an embedded chip, and this is one of the confusions we have, I think, in the market with eSIM adoption, is people think they need to have like an embedded chip in their manufacturing process. They don't. And so that doesn't stop you from adopting the technology. And obviously regular form factor pSIMs are available. As you said, there's the terminology. So when I refer to eSIM now, I think I refer to the technology, not the embedded chip. And if I'm referring to an embedded chip, I'll say embedded SIM, because otherwise, there is a lot of confusion. The change really been driven by, one, there's a big kind of ESG element to it, I think. So there's like the environmental cost of a SIM card and then the eSIM piece. But I think mainly it's to really try and avoid this kind of fear of vendor lock-in and basically having to replace devices or replace SIMs in the field, which we know can cost a huge amount. And so this ability to update OTA in the field at any given time is really attractive to a lot of people. Whether or not we've really achieved that to date within the eSIM environment, that flexibility that it promised is a whole other story. And we'll look at that probably later when we talk about some of the newer technologies. But really, I think it's just the attractiveness really is that remote provisioning piece. You reduce footprint in your hardware, and maybe with iSIM at some point even no footprint in your hardware, which is another step towards the evolution of eSIM in general.
Yeah. One of the issues is that this is all actually relatively new, right? The capability to do remote SIM provisioning, the availability of the soldered SIM form factors. We're still working our way through this as a space, right? It's still relatively new.
Yes, I think so. And I think, as I say, the move for everyone to use just purely an embedded chip, I still think is a long way away. And I think we need a lot more engagement from also the OEMs within the industry, right? Not just the end users of this, to kind of deliver devices when they're bought off the shelf by third parties, already enabled with this technology. And that's really what will drive adoption. Because if it's someone just buying 10,000 devices and putting 10,000 devices into the market, then, they can't really dictate to an OEM necessarily to leverage the technology or onboard it. But at the same time, as I say, there are options for them to adopt it with the kind of PCME UICCs, but the relative confusion about that and the terminology kind of sometimes just requires a lot of education. And it's something new, as you said, for the mass market. I mean, automotive has been using it for a long time, but there's always a kind of period of time where if there's any significant changes or more complexity, then it kind of puts people off because obviously they see it as a risk.
So the main conversation around IoT connectivity and the impact of eSIM is around the handling of remote SIM provisioning. You touched on it a little bit in what you were saying earlier in terms of the ability to manage profiles in field and so on. What's the status with it at the moment? How available is it? And how does it work compared to traditional SIM cards? Well, rather than having to swap out a plastic SIM card, you can do it over the air. But let's delve into that a little bit, can we?
Yeah, so the status, it's obviously been around for a number of years, but I think it's probably good to touch on the historical, I guess, approach to eSIM and the two original standards that were released and how they worked. So initially, when eSIM was kind of first deployed, there was two standards. There was the SGPO2 standard, which was targeted for M2M, and then obviously there's the SGP22, which was more for consumer use, so within smartphones. And so one, essentially, the consumer side was more QR code based and that essentially required two people, right? So, or two devices, or a picture and a device, so you could kind of then download that eSIM. Whereas they developed the O2 environment to work in what we would define as like a headless device, so a device without a screen that can be remotely provisioned. And this was really targeted at IoT devices, and it required essentially an SMGP platform, and which essentially then allowed for electronic SIMs or electronic profiles to be created, loaded into a piece of software, and then basically on request. So you'd send a request in to say, hey, I'm going to send you a new profile. It would deliver that profile to the SIM in the field. And that would, as I say, require SMS, which was also one of its limitations. The kind of goal of that technology was to have this open environment where you could then switch from one operator to another operator. But between MNOs and potentially even between the providers of the platforms themselves, that potentially open ecosystem became quite a closed ecosystem, and so it required a lot of heavy integrations if you ever wanted to switch between platforms or have this interoperability available. And particularly the MNOs themselves weren't super keen to allow you to take their profile off and exchange it with something else. So it really, I think, impacted the adoption of the eSIM, and where we saw maybe some different approaches was around the SGP22 approach. So whilst initially it was designed to have the need for this device to scan something or whatever, there was some non-standardized approaches, which ended up becoming known as kind of like the LPAE, so a local provisioning agent, but within the SIM card, that actually allowed you to adopt the consumer technology within the IoT environment. And so basically you would take the provisioning agent off the device itself and you pop it on the SIM, and then that would allow for you to kind of trigger profile downloads and things via the SIM card itself. And so what we then saw, I suppose, was this kind of a new approach. So we're realizing that eSIM is really important. There's a lot of drivers for adopting eSIM within IoT to really drive down cost, increase security, and really achieve the numbers that we've always talked about. And so there's this new standard, SGP32, which really kind of takes some of the elements of both of the original standards and develops something that's much more scalable and adoptable and truly interoperable between the different carriers and also the different providers of the platform, in order to deliver eSIM basically to the masses. And then I mentioned earlier that one of the drawbacks here is there's still this provisioning agent that's needed on the hardware itself, which isn't a significant piece of software that's required, but it is needed. And I think it definitely delivers the best experience in the new standards, which we can talk about later. But for very lightweight devices, there is this kind of feedback from the market that they can't host or support that size of application. And so there's also now being developed alongside the standards an IPAE kind of implementation, which is then taking again that provisioning agent off the device and putting it onto the SIM card. And that will then make it available to pretty much any device, even if the hardware manufacturers haven't yet adopted the IPAs themselves. So I think there's been a lot of evolution, and obviously some of the benefits I think have been limited to date simply because of the implementation, but we're really seeing that change, I think, and there's a lot of hopes pinned on this new standard. We'll see how it goes.
Yeah, third time lucky is how Paul Bradley at Keegan has referred to it, which I think is probably a fair description. It does drive out a lot of the complexity and makes it more available for use in certain particular deployment scenarios. You don't need SMS on the device, for instance. You don't need user interface. Effectively, it's an evolution of 22, but it does remove some of or adds in some additional features on 22. Certainly a positive thing, we think.
It doesn't require SMS, but what's funny, and I say this is third time lucky, hopefully, but we do see some requests from certain parties to have an SMS variant of 32, so include the ability for SMS to be used. So, the technology is there to remove it, and yet there's this kind of pull back to the bygone era that didn't work for anyone. And so you then question, why are these requests being made? How flexible will it be? Will it be as open as we want it to be? And so on paper, I believe it's third time lucky. But I think the reality, we have to wait until we obviously have the standard fully released, hopefully by the end of the year, and then start seeing the implementations and how people are going about that. But I do agree that this is the best opportunity we have to really see broader eSIM adoption.
Yeah. The joys of standardization, I think I'll refer to in there. I want to talk a little bit about how enterprises are adopting, which vertical sectors, particularly those that might be interested in SGP 32, and maybe how they think of it in the context of some other offerings. Not everything's going to be an eSIM. Some things are going to be multi-IMSI or single IMSI or whatever. So there are a bunch of options for adopters. So how do you see those trends going?
Yeah, as I mentioned, I think so far it's been slower than we expected, but as we said, the standards haven't really delivered what we were expecting from flexibility and interoperability piece. But I think automotive obviously has always been a massive adopter of eSIM, and that's really what drove the initial kind of standards, I think. And I think we're seeing now more the need for IoT devices to be in the field for longer, and that's really also what's really pushing more and more people to really understand the need for it. But from a personal perspective, I've started to see a lot of requests coming from point of sale type applications as well. I think as that kind of market expands with the likes of Square and other Stripe, etc., all these different companies who are now putting devices more readily in the field. Before maybe they were just more online payment gateways, or even banks in particular as well with their handhelds are obviously been connected for a long time, but have experienced challenges with changing technologies and environments, and they're all wanting to secure these devices, not from a security perspective, obviously, but in terms of the lifespan of these devices for as long as possible. I think utilities is another place where we have a lot of conversations around eSIM, and this, particularly in North America, stems from the desire to deploy private networks as well for utilities. So, large utilities are looking to deploy maybe even specific spectrum, like the Antarctic spectrum, for example, in North America. And they are really looking to leverage both the public and private infrastructures. And the path they see to be able to do this most effectively is using eSIM in particular. And then really kind of like any enterprise that's really wanting to deploy globally. I mean, the world is becoming very complicated from a technology deployment perspective. If you look at CAT-M, etc., and NB-IoT, the global rollouts of those is somewhat limited, I would say, versus the expectations maybe 7-8 years ago. So you really need a lot of flexibility in terms of what you're provisioning. We're seeing a lot of regulatory challenges, right, or coming up, and more are happening around the world where you need to be able to deploy a local service in that country versus having a roaming service, and also the changing need for applications for lower latency or lower cost if it's high bandwidth, not being able to rely on roaming as readily. And I think, without eSIM, managing that becomes far too complex, far too expensive. Whereas with eSIM, you can still manufacture a single device and then just provision. And I think with the way that SGP32 works, it allows for a lot more simpler automation, right? Because it's driven from the device. So your device can just say, hey, I'm here, this is where I am. And then, you can use software to say, okay, provision this profile to it. So you can cut out a lot of complexity, I guess, within the provisioning process as well, and the manufacturing process. And then I think you asked about how that can kind of maybe work alongside other technologies like multi-IMSI. And I think they are extremely complementary technologies, because there is still a cost to an eSIM transaction at the end of the day, and it is still slightly kind of clunkier and requires, a certain amount of data to process that profile download. And, if you have a global application and you just want to cost optimize, then you can deploy eSIM almost as a fallback mechanism, but you can, within that eSIM profile that you've developed, have a multi-IMSI applet that's kind of optimizing your global coverage as well. So I think, you can deploy eSIM and multi-IMSI within the eSIM environment readily. And I think it really does add a lot of value for those kind of global applications, particularly ones that are perfectly fine to leverage roaming, but want the option of localization in, say, a Turkey or a Brazil or a UAE where regulation requires it.
One final thing, before we get on to our amusing or amazing tech news section. How do you see things evolving? There's a lot of people who have suggested that SGP32 is particularly a game changer for how IoT connectivity is going to be delivered. Do you see it as that, or do you see it as part of a continuum of how things have always been done? Be interested in that.
I believe there will be elements of it that are game changing for sure. I think it's more, for me, like I was just mentioning, in the provisioning flexibility and the automation of that provisioning that will really accelerate the willingness for people to adopt this cellular technology as the technology of choice, simply because they don't really have to think about it. If you can pre-program a bunch of rules into a cloud, then the device then triggers provision me X, Y, or Z, I think the headaches are almost removed. And you can then use that same technology to cost optimize further down the line. You could set rules in a smart enough cloud to say, okay, if this device, maybe it's using roaming, but if it's been in a static location for 6 months and has been on this network, then provision a local profile on that network and save me however many euros a month. So there's a lot of optimization that can occur as a result of it, I think, as opposed to maybe the fundamentals of the technology changing themselves. I do see it as also quite game changing in terms of how it should open up the environment, particularly for MVNOs, I think. And the value of an MVNO in the IoT space may, be significantly higher moving forward if there is that level of flexibility versus previously where maybe MNOs were kind of dominant because it was just a single MNO on a device, and therefore, why not just work directly with the MNO? But now you want that flexibility. So it'd be interesting to see how the MVNO space evolves around this technology and who can capitalize on that the most. So I do see it as kind of game changing in many ways, but in other ways, it is still very standards based. It probably isn't the most optimal implementation of the technology in terms of creating the most flexibility and reducing cost exponentially necessarily in the architecture. But compared to what came before, I think it's significant. And then I think, and I mentioned eSIM earlier, but I think the next phase of eSIM will also see RSP enabled within the eSIM environment, which is kind of like the next step on from where we are with either embedded SIMs or physical SIMs enabling the technology. So I think we'll see kind of an interesting interaction between the two technologies over the next few years, and particularly for those lightweight, low cost type devices that IoT or mass IoT, I think, will be built on. It'll be really interesting to see which direction that goes in from an eSIM perspective, but with the flexibility of eSIM technology within that environment.
So we could talk about this stuff for hours, but we're going to have to bring things to a close. But as mentioned, what I want to do right at the end is, we ask our guests to bring along a light-hearted or amazing tech news story they've seen recently. What's taken your fancy there? So.
Yeah, I think less the kind of a specific story, but more kind of, I guess, a use case. And I think, there's IoT sometimes kind of trivialized a little bit, right? With use cases like ordering milk from your fridge, ordering your milk or something. But I think IoT's benefits just go so much further than that. And I think one of the things that we've had a couple of customers doing, and I think really interests me, is how animals and their environments that are generally under threat, and now more than ever as human technology advances, are really being helped and are really benefiting from technology driven via IoT. So, whether it's, from perimeter monitoring to kind of, protect from poachers, or whether it's crowdsourcing data of marine life to kind of review, to understand, whale locations or numbers or fish stocks, or even just kind of proactive alerting to infrastructure companies. So train lines, for example, if there's I think the one I read was about a herd of reindeers that were often getting hit by trains in the Nordic countries that are going fast, and the train drivers can now be alerted to the herds, and they can slow down a little bit and hopefully save some lives, as we all want our Christmas presents delivered on time, obviously. And so and even then to honeybee monitoring and things, which is something a customer of ours has done for like 10 years or so. But obviously the bee's importance to the ecosystem is hugely important, and that obviously impacts us directly. So I think for me, it's just how IoT can be used for good, and I think there's so much we can do in the future if we kind of get to the point where we're sharing data more broadly within the IoT ecosystem, and really connecting the dots between all these different siloed applications and pieces of infrastructure to really benefit the populace, and also obviously everything that keeps the populace going and makes our planet special. So I think that's kind of my positive kind of view of IoT story. Yeah,
excellent stuff. As a beekeeper myself, I can only echo that, although it's terrible thing that I've not actually adopted any IoT solutions to monitor my beehive. So
because you keep them so well in.
Yeah, well, maybe it's that I'm constantly in there, right? So it could be that. Okay, so my funny news story, kind of funny. There was a report out just this week about China looking to supercharge adoption of mobile IoT. So it's going to establish some IoT industrial clusters, some industry demonstration bases. It's going to strengthen the foundational IoT network and do a whole raft of things that it announced in order to try to drive further adoption of cellular-based, particularly IoT in China. This makes me laugh a little bit because currently, or rather at the last count, around about end of last year, China accounted for about 2/3 of the world's cellular IoT connections. Depends how you count it, but certainly they're punching above their weight already. So it kind of made me laugh a little bit because maybe it's actually the rest of the world that needs this rather than necessarily China. But
certainly does
yes,
give a positive indication to the size of the remaining market in the rest of the world, though, as well. I suppose. So, that's a kind of funny way to look at it. But evidently, there's even more potential there as well than beyond.
Absolutely. If the rest of the world can catch up, it will be billions and billions of devices.
Yeah.
Excellent. Sam, it's been an extremely interesting discussion. Thank you so much for joining us.
Thanks for having me. It's been great. So, yeah.
And with that, I will draw the podcast to a close. Just a reminder that you can subscribe to the Trending Tech podcast wherever you found us today. And indeed, thank you for joining us. And we're delighted to have you listening in as part of the growing audience around the world. We'll be back with another edition of the Trending Tech podcast soon, focusing on another aspect of digital transformation. In the meantime, please keep checking IoT-now.com, vanillaplus.com, and where you can find more tech news, videos, top-level interviews, and event reviews, plus a whole lot more. Thanks again for joining, and bye for now.
Thanks.